All right, folks, so this video is going to be about how to represent polar points in more than one way. Unlike in the XY coordinate plane, where there is one and only one way to name each point, polar is a little bit different in that there are actually four different ways that we can use to represent that same location in space. We alluded to this, or we talked about this a little bit at the end of the video from yesterday, so this discussion is kind of going to pick up right where that one left off. All right, so without further ado, let's go ahead and jump right in. The directions here I'm going to modify just a little bit. It says for each polar point, plot it and name it two other ways. I'm going to change that word or that number of 2 to 3. As long as we're doing this, we may as well go all in. All right, so first thing that I'm going to do is go ahead and plot that point whose radius is 4 and whose angle has a degree measure of 60. So I'm going to start on my pole and on my polar axis. I'm going to go find the angle whose terminal side is at 60 degrees. And I'm going to count outwards from my pole 4 units. So there, folks, is the location of point A. And again, I can go 60 degrees in a counterclockwise fashion from my pole. And as we talked about in the previous video, another way to name this would be if I went clockwise from that pole. And in this instance, I would have to go a total of 300 degrees. And in the negative direction, so another way to name that point would be 4 comma negative 300 degrees. And like yesterday, pay close attention to the fact that those two angles are indeed coterminal. Their terminal side is in the exact same location. And I'm going to say, instead of along that 60-degree mark, what if instead the terminal side of our angle were 180 degrees opposite that? So what if we were looking at a terminal side that ended right there? If that were the case, then we could go and we could find an angle whose radius was -4, reflect through the pole, and still end up right in that same exact location. So our other two angles are going to be the case scenario when the radius is a negative. So in this case, our radius would be -4, and we have to find two different ways to name that terminal side. Well, one of those ways is if we start at our pole and we go in the clockwise direction, counterclockwise, and that looks like that's 240 degrees counterclockwise. And if we were to go in the clockwise fashion, of course, our angle measure would be negative, and that looks like minus 120 degrees right there. And those last two angles, like the first pair, notice, are also coterminal. They're just coterminal in such a way that they're directly opposite or directly across from the first angle. All right, like yesterday, I'm going to go through and I'm going to do some erasing now, just so that I can avoid my picture becoming too cluttered or too busy. So I'm going to leave my pole there, I'm going to leave my polar axis, but I'm going to get rid of everything else so that I can go ahead and jump into the second example. So in letter B now, they're telling us that they want us to plot and find three other ways to name the point whose radius is -5 and whose angle measure is 315 degrees. So first thing I'm going to do, like always, is go find the 315 degrees. 315 degrees is going to be right smack dab in between 300 and 330. The fact that that radius length has a negative in front of it tells me that I have to reflect through my pole. So I'm going to go across from or opposite. And I want to count on my radius 5. So there's the location of point B. All right, so I'm going to name it first by keeping the radius the same, but finding another way to name that angle whose terminal side is there on that purple ray. So if I were to go clockwise from my polar axis, it looks like I'm going the 360 minus 315, or 45 degrees, but in a negative direction. So an angle measure of negative 45 degrees. And again, I want to reflect through that pole to end up here at location B. So my radius length would be -5 if that purple side were to be my terminal side. If I wanted to name the orange as the terminal side of my angle, I have to figure out what that orange angle is right in there. And it looks like from my graph that I'm exactly halfway between 120 and 150. So I'm liking 135 degrees. But if I'm going 135 degrees, now when I count out, I want my radius length to not be reflected through the pole, so to just be a regular +5. And of course, I can also get there by moving the other way in the clockwise direction from my polar axis. And that looks like it's going to be -225. So 5, -225 will also land me right at that same spot. Notice or pay attention to the fact that those angles are always coterminal angles, always. You will always have two positive R values and two negative R values. So always coterminal angles. And two pairs of them. Always two positive and two negative values for R. All right, I'm going to move on and take a look at these other these other four down at the bottom. If you feel like you have a pretty good handle on them, then maybe you want to pause the video and just check your answers at the end and make sure that you're indeed spot on and that you really have your brain wrapped around this and are in a good spot with regarding plotting these points. If you're feeling like you could use a little bit more instruction, stick around with me and we'll go through and we'll do these together. So letter C says plot the point with coordinates 2, -90 degrees. So I'm going to start with that -90 degree angle. So -90 degrees is going to land me right down here. I'm going to go 2 units out from that pole. So there's the location of letter C. So again, there's my -90. If I were to go the opposite direction from that polar axis, I'd have to go a positive 270 degrees and my radius length would still be 2. So 270 is another way to name that. And if instead I was looking, or if instead of looking on that light blue ray, I were to look 180 degrees across from it, so on that pink ray, I could go up there and have a radius of -2. So that's going to be a positive 90 degrees in the counterclockwise direction, negative 270 degrees in the clockwise direction. So if I were to make my R value negative, again, I could have -2 with a positive 90 degrees, or -2 with a -270. But again, notice or pay attention to two positive R values, two negative R values, always those pairs of coterminal angles. Letter D is interesting because we're getting into some radians. And this is an important time to note that if they give you the measure of the angle in degrees, you're going to give your answer in degrees. If they give you the measure of the angle in radians, you are of course going to answer in radians. All right, so let's see what goodness lies in store for us here with letter D. So letter D says -6 comma pi over 6. So if I think about the location or the whereabouts of pi over 6, there's pi over 6. So there's the terminal side of my angle. My radius is -6, so that means I'm going to have to reflect through that pole. And on that ray, I'm going to count out 6 units. So there's letter D. And now I have to come up with three different or three more ways to name that. So the first way, I'm going to use that same pink ray, and I want to go all but pi over 6 all the way around the circle. So one complete revolution around the circle is going to be 2 pi, or in other words, 12 pi over 6. I'm falling short of that by pi over 6 units, so that would be -11 pi over 6. So -6, -11 pi over 6 would be a second way to name that. And then my other two ways are going to name the angle in the light blue, or have its terminal side on the light blue instead of the pink. So I need to have the number of radians in that angle right there. Remember that pi is really 6 pi over 6. We're going pi over 6 or 1 pi over 6 past that or beyond that. So that would make my angle measure 7 pi over 6. And this time I'm going to count right on that ray. I'm not going to do any reflecting, so I'm going to make that radius a positive value. And now if we were going to make that light blue our terminal side, but with a clockwise rotation from the positive x-axis, now we're taking a look at -5 pi over 6. And again, this time our point is right on that ray. There's no reflecting to be done. So I'm going to indicate that with a positive radius. All right, a couple more here. Let me go ahead and clean things up a little bit. Things got a little messy with the radians there. All right, letter E says 1 comma 5 pi over 6. So again, I'm going to start first, I'm looking for a different color here, with 5 pi over 6. So 5 pi over 6 is going to have its terminal side right there on that green ray. And I want my radius here to be 1, so right in close to that pole. So that's going to be my point E. And if I were to go from my polar axis but in the clockwise fashion, well, now in that case I'm going -7 pi over 6. So 1 and -7 pi over 6 would be that exact same location. And if I were to instead go on or use the ray that's directly across from or opposite that green ray, I'm going to go clean things up a little bit here to try to keep my picture neat. I don't get to use yellow very often, so let me go for the yellow. So again, my reference angle there is pi over 6. So if I'm starting on my polar axis and going in the clockwise direction, that's going to be 11 pi over 6. But in the instance that I ended on that yellow ray, I would have to reflect through my polar or my pole to get to point E, so my radius would be -1. So -1 and 11 pi over 6 will also name that same point. And if I were to go clockwise to that yellow ray, well, that would be -pi over 6 with a radius of -1. I'm hoping at this point you've got a pretty good handle on this, but we've come this far. May as well finish this off for good measure. So -3/2 with an angle measure of 5 pi over 3 for the last one. And again, I'm going to go clean things off so that I can start with a clean slate here. All right, so first thing I have to do is plot the terminal side of my angle. That's going to be at 5 pi over 6. So there's 5 pi over 6. I'm going to make that nice and big. And my radius length is -1.5. So I'm going to have to go across from or opposite or reflect through the pole. There's my letter F. So if I'm going in a clockwise fashion to get to that blue ray, I'm going to be at a negative, I guess that was -5, or sorry, 5 pi over 3. I'm going to have to be at a -pi over 3 here. So -3/2, -pi over 3. And if I were to instead want to make my radius a positive number, and I just erased where I wanted to go. I would instead want to end up right on that orange ray. So if I'm going from my polar axis there, that angle measure is going to be 2 pi over 3. And this time my radius is a positive number. So 3/2, 2 pi over 3. Or if I'm going in a clockwise direction from that positive or that polar axis, remember I'm coming 3 pi over 3 around to halfway around the circle and a pi over 3 beyond that. So -4 pi over 3 with a positive radius. All right, that's all I have for you today, folks. There are no questions to answer in Delta Math. Your homework is going to be on page 9 where there are no directions, but I'm going to say I want you to name each point in 4 different ways, so give 3 additional ways. And the same with page 10. Name each point in 3 other ways. All right, hopefully I will have kicked this thing by Monday and I'll be back in action. Until then, though, feel free to reach me in Teams or by email. All right, take care. Have a great weekend. Hope to see you all soon.